We are in the quadratics unit looking at our second practice test, going through each problem to make sure we have a good sense of mastering all of the essential content. First part is looking at a graph and trying to work backwards to key elements of a quadratic. So a lot of this is going to be heavy on the vocabulary and recognizing elements present. So we have line of symmetry, the min-max, and the vertex. Those all work together as one essential section there. We have our intercepts, X and Y-intercepts. And then we have our width coefficient, A, it kind of gives, it's like a slope for a parabola, not exactly the same. And then we have two different equations, a vertex and a factored form equation that you can write given the information we have above. So let's start identifying these things. Line of symmetry is where things are symmetrical. So where things are all mirrored. And in this graph here, if we were to draw a mirrored line, it's going to mirror right there at that vertical line that goes through the vertex, this point right here, which we'll get to in a moment as well. So that line has a name. It's every value of y is different along this line, but every value of x is always going to be positive 3. 0, 0 is over here. We go 3 over, and so we're looking at a positive 3 for x. So x equals 3 is going to be the line of symmetry. Next thing we're going to look for is the min or max, which is essentially the y value of our vertex. We are trying to figure out how high up in the air we are. And so that point occurs up there at a height of 4. Since the graph is facing downwards, that is the max of the graph. So we'll select max. That means our vertex is going to be the x value from the line of symmetry, 3, and the y value from our min-max, which is 4. So 3, 4 is that point right up here where the graph turns around. X and y-intercepts, we look at where it crosses the x-axis and where it crosses the y-axis. So X-intercepts, we see that we are crossing the x-axis here and here at x equals 1 and 5. So we have 1 and we have 5. And we don't put parentheses around it because it's not a single point. It's actually two separate points, the point 1, 0 and the point 5, 0. But we can just write 1 and 5. The y-intercepts where it crosses the y-axis, that's going to be way down below here at negative 5. So we can write that in as well. And we're just getting this shown all from our graph. A value. So the width coefficient A value, it acts like a slope. When A is negative, the graph is facing down. When it's positive, it's facing up. The way you can get this easily is by starting at your vertex and going over 1 and then seeing where you go from there. In this case, we have to go down 1 to get back to our graph. So we're going to have an A value of negative 1. The reason it's not truly a slope is because if we were to go over 1 more, we would find we're not going down 1. We're actually going to go down a larger number, and that's because the x squared part of a parabola makes it a curved graph, so it's not having the same slope everywhere. We're going to use that information we just collected to write our equation in vertex form and in factored form. Now, the equation's always going to relate y to x, so I'm always going to put y equals at the start. And the very first thing in both of these forms, both the vertex and factored form, is that A value carries over. That carries over into standard form as well, so kind of everywhere. And so we're going to put that negative 1 right up front. Now the vertex form looks at shifting the parabola, the y equals x squared graph, which is where we normally start. And it shifts it left and right along the x, and it also shifts it up and down along the y. So that shift is going to occur by looking at where the vertex is. And in this case, our vertex is at 3, 4. And so if we look at that positive 3, it means we had to move to the right 3. The way you do that with the translation is you write it as x minus 3. And if you're wondering why minus would move it to the right, to the positive direction, it's because when you plug in 3 for x here, 3 minus 3 is 0, it acts as if it were at 0, 0, which is where it normally starts. So x minus 3, that translates it 3 to the right, and then we still square it just because we have a parabola. It's always going to be an x squared graph. The end of it is going to consider that y value of 4. That means that we are up 4 units with that vertex, and so we are going to need to put a plus 4, because that plus 4 at the end just shifts the y value up a full 4. And that's our vertex form. That is always going to follow that basic form. So if you were looking to have something in your notes that you could reference, y equals a, parenthesis x minus your x value, I'll leave a blank there, squared plus your y value of your vertex. And remember, vertex form is always going to reference the vertex. Now the equation in factored form is going to work the same way, except this time we're going to use the factors to drive that. Our factors are the same as our x-intercepts. So factors match up with x-intercepts. And our x-intercepts are positive 1 and positive 5. So we are going to write two things, two linear parts, the x relating to the 1, in this case x minus 1, and x relating to the 5, x minus 5. Just like with the x minus 3, how when you plug in a 3 it goes to 0, x minus, or if we plugged in that 1 minus 1, we would get 0 there, which is what we want for a y value on our x-axis, because along the line y equals 0, that is the x-axis. That's where these points are occurring. Same thing with the 5. We do x minus the positive 5. If these were negative x-intercepts, we would actually do x plus, because it'd be minus a negative. So let's see if we can repeat that same process here for a second one. So line of symmetry is going to be the line where everything nicely folds in half. It's right there at 1 back from 0, so x equals -1. And the x equals matters because it is the equation of a line, not just a single value or a number. We have a height down here of -3. That is the lowest the graph will ever go. So that is our minimum at -3. And that means that together those two make a vertex of -1, -3. X-intercepts, we get that by looking at where it crosses the x-axis, which is going to be these 2 points. Generally with a parabola, you're dealing most often with 2 points, not always. And so that's at 0 and at -2. Our y-intercept is where it crosses the y-axis, which in this case also happens to be at 0. Whenever the x-intercept is 0, it means you're also crossing at 0, 0, so you're going to get it for the y as well. The width coefficient a, that's where we start out at our vertex, go over 1 and decide how far up or down did we go. In this case, we went up a +3, so a is 3. We can use that all to write our equations now. So our equation starts out with y equals for both. We always reference our a values for both, so in that case it's 3, just like we would in standard form later as well. Vertex form is going to reference the vertexes, x minus our x coordinate of our vertex, so x minus -1, which means x plus 1. Minus a negative is plus. We still square because it's an x squared graph. And then at the end, we take our y value plus a -3, or just -3. The factored form is kind of the undistributed version, as if we had factored out the full equation. And so that one is going to have x listed twice and no exponent. So instead of folding it up into a single part with x, x is written twice. And it's x minus each of those two x-intercepts. So x minus 0, we could just leave it x. If you wrote x minus 0, it wouldn't be wrong. It's just not really that cleaned up. But you could just write x. X minus -2, and just like we did above, that's going to be x plus 2. And so that is fully finished up there. Last part down here is finding X and Y-intercepts. And so whenever we want to find the X-intercepts from the factored form equation, we can just do the opposite of what we did up here, which is to say what makes each of those factors, those groups, go to 0. What would make x plus 5 equal 0? Well, if x equaled -5, -5 plus 5 would equal 0. And the reason why that matters is 0 times any number here and any number here is going to give us an answer for y of 0. That's how we know it makes an x-intercept, because it makes y equal 0. This value right here, what could we plug into this set of parentheses to make it 0? Well, since x is the only thing in there, it would be 0 itself. So -5 and 0 are going to be our two x-intercepts. And we'll label those. The y-intercept is the opposite idea. So instead of trying to make y equal to 0 for our x-intercept, we're going to make x equal to 0 and see what y becomes. So let's take our -1 times our 0 plus 5 times our 0. -1 times 5 times 0. Well, anything times 0, our y-intercept is going to be 0. Now, it doesn't always become 0, because many times it's going to be like x plus 1 or something like that, and that's going to cause this number not to be 0. So the y-intercept is sometimes 0, but usually not.